Does Cheryl know that? As long as Cheryl knows it, it's all
Yes.
good. All right, then we have no trouble.
Okay.
Allison, you're muted if you're talking.
Now I'm talking. Thanks,
Okay.
Glenn. All right, everyone. So I'm going to just go ahead and give you all a quick welcome here. So this is our first session of the morning in room 2. My name is Allison Owens. I'm the project team coordinator for ITEN. So today we will begin this session with our team from Barbados, Louisiana Tech University in Louisiana, United States, and Shortwood Teachers College in Jamaica. So I will go ahead and turn it over to the team here in just a moment, but just so you're all aware, you do have the option of interpretation if you have not already found that. Entonces, mejor en español. Si no han encontrado todavía la opción de interpretación, allá abajo en la barra de funciones de Zoom, hay una opción de cambiar el idioma al español. Okay, so I think we're good to go, everyone. Just a quick note, if you have not already and you entered via GatherTown, please go ahead and close out your GatherTown or make sure that your microphone and your video are closed on the other platform so that you can properly hear and see on Zoom. All right, thank you, everyone. I'm going to go ahead and pass it over to our team and let them get started with you. Have at it, team.
Thank you.
Thank you, Allison.
Okay. Addison, can I screen share?
You're all set.
I'm you all set now? Okay. All right. Let me share. Great.
Welcome to our presentation on effective STEM lesson planning. Our team's vision. If we provide teachers with a comprehensive lesson planning model, then this will allow them to construct a solid foundation on which to improve the teaching and learning process. Our team's achievements. We developed a lesson planning needs survey and an inquiry-based integrated STEM lesson planning model for grades 4 through 12. Our lesson planning model was pilot tested with a primary school teacher in Barbados and is being pilot tested with pre-service secondary teachers in Jamaica. Our goal: to create an effective lesson planning model to be used by pre- and in-service teachers. Stay tuned for more on effective lesson planning. Let's meet our dynamic project team members. First up, we have Bhagya Malladi. This lady's technological repertoire is extensive. She currently teaches at the Immaculate Conception High School, where she is a master teacher and the LASCO MOE Teacher of the Year for 2019 to 2020 and an ITEN Teacher Fellow. Let's welcome Mrs. Malladi. Next up, we have yours truly, Miss Janille Malcom. Welcome, everyone. I am also at the Immaculate Conception High School, where I am senior teacher, and I will be your moderator for this morning's presentation. From the Garden Parish of St. Anne in Jamaica, we have Mr. Conroy Hall, the team's own Mr. Cool. He is a mathematics and physics lecturer at the Shortwood Teachers College, an author and an educational technologist. Let's welcome Mr. Conroy Hall. Our next team member is affectionately known as Uncle Glenn. You can count on him to find the simplest yet effective solution for any scenario. Mr. Glenn Larson comes to us from Louisiana in the United States. At the Louisiana Tech University, Uncle Glenn, as a master teacher, works with the program You Teach Tech to overcome the shortage of STEM teachers in the US. Guys, what did I tell you? A true problem solver. Welcome, Uncle Glenn. Next up is another master teacher who is also involved with the You Teach Tech program at the Louisiana Tech University, Mr. Chris Campbell. Now, who would have thought that this reserved individual would have done skydiving in his spare time? Welcome, Chris. This member represents 2 islands and is affectionately known as Jambarb. Her roots began in Jamaica, and she shares her pedagogical wisdom with any educator she meets, face-to-face or virtually. This nurturing soul is currently a senior lecturer at the University of the West Indies, Cave Hill Campus, Barbados, in the Department of Curriculum Studies. Thanks so much for your many gems, Claudette. Welcome, Claudette, everyone. And finally, our next team member is a reserved but passionate and dynamic educator from St. Angela's Primary School in Barbados. This gentle soul has taken on the monumental task of bringing STEM to her island's young minds. She makes it look so effortless. She is Miss Cheryl Sobers. Welcome, Cheryl. And now let's go to our first presenter, Mr. Glenn Larson.
Good morning, everyone, and welcome. As Janille mentioned, we started out coming up with an idea of a template for lesson plans and also a questionnaire. So I'm going to talk to you a little bit about the questionnaire. The first section of the questionnaire was we were trying to find out what current practices our students were actually using right now. So we had a series of questions that were asking them, did they think about certain things when they did their lesson planning? If we can go down to the next one. Yes. So this is just a sample question. We used a modified Likert scale and asked them if they agreed or disagreed that they thought about certain things when they did their lesson planning. The idea was that if we could find out what things they didn't think about that we thought they should be thinking about, we could make changes to our own training and or maybe our own program. The next section was questions 16 through 17 and 18, and this is questions where we were asking our students if they struggled in certain areas when they were traditional classroom. I struggle with, and then we gave them a list of possible places where they might have struggled. Our students in Louisiana basically struggled with differentiating content and activities and assessing the quality of the lesson. And assessing the quality of the lesson, you'll see, is a recurring theme in this. When we went to question 17, here comes 17. This is an area of struggle when implementing lessons in a virtual classroom. So in respect with COVID-19 and what's going on in the world, we decided we wanted to look into virtual lessons as well as just in face-to-face lessons. So we're asking questions about, in a virtual classroom situation, what kind of things did you struggle with? And our students in Louisiana found trouble again with assessing the quality of the lesson, administering a variety of assessments, and also conducting experiments. So this, of course, is an issue with the whole COVID-19 and distance learning. We didn't have a lot of experience doing this, and of course, because of that, our students don't have a lot of experience. Something we're definitely going to look at in the future. Question 18. Question 18 was areas of struggles in implementing lessons in a traditional classroom. Janille's hiding it from you, but she'll bring it up here in a second. But when we asked these questions from our students in Louisiana, we had, again, assessing the quality of the lesson and monitoring and managing differentiated activities. So for us, and I think Conroy is going to talk about whether or not Jamaica had similar issues, we're definitely going to look at differentiation in all its aspects in our program and make sure that our students are more prepared. And we're going to look at whether or not we need to schedule some extra workshops in certain areas. And I think next is Con.
Good morning, everyone. I'm now going to present on the findings from Jamaica. This survey was conducted with 12 third-year science students. Out of the class has 14, but only 12 persons did this survey. From the result, we found out that majority of the students taught physics, and we have about 12%, 18% that taught integrated science, biology, and chemistry. When we asked the question on how the students implement the engineering and science practices in the lesson planning, we found out that most of the students incorporate engineering and science practices in their lesson. But it went down when we look at the mathematics practice. We found out that about 50% of the student teachers actually consider the mathematical practices when they are planning their lessons. The challenges that we face as we look at numbers 16, we found out that the student had challenges with meeting the needs of the students when planning their lesson. And in addition to that, they have challenge in terms of differentiated instruction, in terms of the content, and in terms of the assessment. In order, when we look at the implementation of lesson in a virtual sense, we found out that the student had challenges with the asynchronous and the synchronous component of the virtual space. In addition to that, the student also struggle with conducting virtual labs. When looking at the, yes, so they had problem with the virtual labs. Could we move to number 18, please? Thank you. When we look at implementing the lesson in a traditional classroom, we found out that the students struggle with the integration of the synchronous and the asynchronous, and also to manage and to monitor the differentiated instruction. And so, as similar to Glenn students, we found out that the student had major challenges with differentiated instruction and how to use asynchronous and synchronous tools in their classes or lessons. Based on what we observe from the questionnaire, we look at how we can help the student better write effective lesson plan. And so what will be shared with you is a lesson sample plan that was taken from a collection of lesson plan created by second-year students. And so this lesson plan was actually from the student who this survey was conducted to. Now, when we analyze the lesson plan, we found out that in addition to the findings that we that came to us from the questionnaire, we found out that the student had challenges in terms of writing the objective, especially the affective and the psychomotor domain. And so as a result of that, I have conducted a workshop dealing with that aspect. In addition to that, there's a positive correlation with the questionnaire that the student had challenges in terms of differentiated instruction. And so when perusing the lesson plan, we found out, although they follow the 5 E's, and so they have the engagement, the exploration, explain, and evaluation, the students were missing a very key or a key component, and that was the differentiated instruction. And so there was no differentiation in terms of the content, in terms of the instruction, which is the process, and also in terms of the assessment. In light of that, I have created a PowerPoint presentation to deal with that aspect. And this PowerPoint presentation would deal with, one, differentiate instruction, how to actually use a PowerPoint simulation in a virtual classroom and also in a traditional classroom. The emphasis was also placed on questioning techniques, and so if you look at this introduction, what I use stimulus, and so I use pictures to aid my questioning. And so I was dealing with capacitance, and so I linked that to the mathematics concept and also the real life concepts. And so I was able to bridge the gap. So what I intend to do is that I'm using this PowerPoint presentation with other resources to help the student to deal with differentiated instruction, to deal with asynchronous and synchronous tool in terms of the virtual classroom, especially what is happening to us right now with COVID-19, and also in a traditional sense. Now, I also embedded a video where the students were able to see how I use the video, as a tool to enhance the concept, and also it could also be used in terms of a virtual lab. So the student will actually go out and conduct this lab without I being with them. And so it could be offline and also online. So my colleague will now share with you a minute of the video.
What I want to do at this point
Conroy, the volume on the video is not playing. Oh, I suppose that's
It's okay.
Janille. Apologies.
I figured it out. It was
Okay.
muted. Sorry
Oh,
about
great.
Sorry about that.
voltage.
That's okay, no problem.
0.5 at this.
Oops. Sorry about that. Just using my fingers. I'm very sorry, guys. Hold on. Let's see.
1.5 at this point. And
There we go.
What I'm looking at is the capacitance. So as I move it, and as you can see here, what do you notice? That the capacitance is not changing. I go back here. Now let's see what affects the capacitance of this. And so I'm going to go to the distance first. And so the distance between the two plates, this is what distance we're talking about. And so when I increase this distance, what do you notice? You can see something's happening with the capacitance.
So I will use this video to explain the concept that we can use something like this in an offline and in an online setting. So the asynchronous and the synchronous component, I will deal with that using this video, and also the differentiated instruction.
Good morning, colleagues. So I'm going to be talking about a model that we developed for effective lesson planning at the primary level. We took two approaches to effective lesson planning. We sent out a survey, as you heard from Glenn and Conroy. We sent out a survey to teachers to assess their lesson planning needs. Now, the approach that we took in Barbados was a single case study. So I worked with one other person, Cheryl, who is here in the panel. And together we looked at Cheryl's lesson planning needs and Cheryl's struggles with designing STEM-infused, inquiry-based lessons. Based on hours and hours and hours of conversations, we came up with this particular model that we situated within Cheryl's particular context of primary school teacher in Barbados who is required to teach all the subjects in the curriculum. So if you notice, the first part of the model is showing, you can see steps 1, 2, and 3, which in fact are the most important steps. And those represent the pre-planning. Lots and lots and lots of work goes in at this stage. So at stage 1, you have to assess your learners' needs as you normally do. And Cheryl will talk about how important that was when she was implementing her STEM lesson. The next section, which is the integration of content, is really quite challenging because you have to look at, and this is what we did together, we looked at all the science learning outcomes for the topic that Cheryl had chosen. She chose weather and climate. And then we looked at, she teaches a particular level, class 3 in Barbados, which is grade 5. So we looked at all the science learning outcomes for grade 5 weather. We also looked at all the outcomes for grade 4 and grade 6. So the grade below and the grade above. In addition, we looked at the math learning outcomes for the same grade level and the English language outcomes. Cheryl, Janille, can you stay up? Just stay up where you were, please. So I'm talking, yeah, thank you. So she looked at science learning outcomes, math learning outcomes, and English language arts learning outcomes for her class. Because remember, she's teaching all of these subjects. In the next step of the model, we looked at integrating STEM. Again, this was quite challenging because in order to do that, the teacher has to have quite a wide foundation. The person, the teacher has to look at the NGSS science practices. You have to look at the NGSS engineering practices, the NGSS disciplinary core ideas, cross-cutting concepts. All of these things were new to Cheryl, but all of these are essential if you are going to be planning an integrated a lesson or lessons that integrate STEM. Number 4, we used a unit planning approach because in that way, all of this general information that Cheryl had collected, so all of the learning outcomes across math and science and ELA, and then all of the information that she had on STEM, those pointed towards the general picture of what she would be doing across her lessons. She also chose at that point the level of inquiry that she was going to implement in the lessons. So the model points her to inquiry. She can't escape the inquiry. And then she planned the lessons. Okay, so I'm going to hand you over now to Cheryl, who will talk about her reflections on one of the lessons that she implemented. Thank you.
Cheryl, you're muted.
Sorry about that. I didn't realize I was muted.
No problem.
Good morning, colleagues and friends. I'm going to talk about my reflections on the primary STEM planning model. The topic I chose, as Claudette has said, was weather and climate, but I looked specifically at the patterns in weather to make predictions. The time allotted to me was pretty short. It was 80 minutes, and that 80 minutes was during the week for 2 classes, the parallel class, along with my class in class 3, which are 9 to 10-year-olds, grade 5. So the first thing I did was try to get to know my students. I'm new to the school, and the students are also new to me, as well as I am new to them. And therefore I had to find out where they're at, what stages of, what concepts they knew beforehand, before coming into this lesson, and also what math skills they had that would be integrated as well. I had to know what level they were at in their math and other areas, English lessons, English language, etc. So within the STEM plan, go back up a bit there, right. So to look at how the STEM planning model facilitates effective lesson planning, I focused on the importance of the science and engineering practices of the lesson. This encouraged me to think about how I interacted with them. As I said, I interacted with discussions. We discussed the weather and climate, the weather versus climate definitions. We also discussed it about how they perceived the atmosphere and what that meant to them beforehand, and what they came with, the knowledge that they came with beforehand. Okay, I also found out what their likes and dislikes were, so to find out what type of learning strategies I would use. Audio, visual, tactile will be used to help them learn. How does the STEM model facilitate inquiry-based learning? I focused my choice on the using guided inquiry, and that was done with while they were trying to be, as we discussed the weather issues and the weather content, and also with while they use the videos to learn how to make the specific devices that we were using. And at top, you can see that I use 3 specific devices: the wind vane, the rain gauge, and the anemometer. Those are the specific devices that I use. Just a minute, go back up a bit, right. So the NGSS disciplinary core ideas that I use, which is important, was that scientists record patterns of weather across the different times and areas, and make predictions about these kind of weather. The fact that we're doing it now, I chose to do this now because we're in the hurricane season in our region, and I will be looking at not only what they would do on site at the school, but they were taking their devices home and taking data from home as well in the different areas around Barbados, because we have rainfall in some areas more than others, and the different, they will be looking at the data from different areas and different times in that way. I could go ahead, Janille, you could go further down. So how does the model facilitate integration? Right. So what I integrated here, I integrated math concepts and math outcomes, English learning outcomes, as well as the science and engineering practices. We had to measure the amount of rainfall in the rain gauge that we see here. And the children had to use the particular type of, we call them pet bottles. And they're normally the 16-ounce ones that they use, and all of them use those. One or two children did use different ones, but they measured them in length from where the rocks were, and then measured up in, we were going to use millimeters, but they realized millimeters in the rainy season might be too small unit to use. So we decided to convert that to centimeters and use centimeters. Some children have expressed that their rain gauges are overflowing and they had to therefore record how much they had, dump that, and then start again because of the amount of rainfall that they gathered in their rain gauges. The numerical data that we collect, we will present that in forms of bar graphs, pictographs, drawings, line graphs, and they will be able to demonstrate them or use them, hopefully using Adobe Spark and different forms of media to present their work. In English language, we were able to use, I was able to use a lot of the spelling and vocabulary words in English language. And therefore, instead of taking from books in different areas, I use the science vocabulary in English language for spelling and their vocabulary. So they made sentences within English language using their weather vocabulary. Can you go down now a little bit further? Janille, right. So the challenges that I came across were actually having the knowledge of what is needed for STEM and the technology standards, especially the technology standards, and being able to actually use them and implement them. In implementing the inquiry-based science, it took longer than I thought. So the two lessons I started one lesson on water cycle, and then I went into the weather instruments. Those two lessons, I have to now stretch them over time because with the troubleshooting that the children did a lot of in their engineering and their construction of the devices, it took a lot of time for them to be able to finalize that product. So with that, they had to take them home and do them. The data will be collected over the time of 10 months because I want to go into the dry season as well, so we can compare our findings and our data and therefore be able to predict well, or hopefully predict well over time, what we expect in the future in 2021 and 2022, the weather outcomes. So those are my findings, and that is, I'm going on to I'm finished there. Right, so I'm not going to talk on this, Janille, because we mentioned that already in what I just said. These are all the learning outcomes and everything for English language, math, science that go according to our syllabus. So thank you.
Janille, so sorry, you're muted.
Janille, you're muted.
I'm so sorry, guys. So I was saying, right, that we started off looking at the questionnaire. And so we were able to identify the concerns of our pre and in-service teachers, both in Jamaica and in Louisiana. And we recognize that there is need for continued work with these teachers in developing effective STEM lesson plans. We also saw the importance of the pre-planning process, knowing your learners, taking into account the science learning outcomes, and most importantly, integrating STEM. And we saw an example of a fully developed STEM lesson plan. All right. I do hope you enjoyed our presentation thus far. We also have some guidelines on effective STEM planning. Mrs. Malladi would like to share a few thoughts.
Good morning, panelists and attendees. And to add to my team members who have actually did a presentation on how to make an effective lesson plan, I would first I'm very glad to let you know that to do this presentation, we did use Google Sites. And by using Google Sites, it has helped us to collaborate and it has empowered us with the 21st century skills. Keeping that in mind, our main aim is to meet the needs of our students. Now, being in the virtual space, especially now during this COVID-19 pandemic, it is very important to design our lesson plans for both synchronous and asynchronous learning and integrate STEM into the curriculum. So as educators, while we are planning our lessons, we must ask ourselves a few questions, as you can see above, and then we can use the Assure model and the UDL model to help us to design an effective lesson plan. Now, when we are using the UDL principles, it helps us to give our students multiple means of engagement, multiple means of representation, and multiple means of action and expression. And definitely and surely, I am sure that you'll agree with me that active learning in the present situation is very, very important, because through active learning, we must bear in mind that students need not have the technology, I mean the devices, but they can use the low-tech tools and we can help them for their action and expression. So you can see some of these models which were made by my students, and then we come online and we have a good discussion about it. So effective lesson planning must help us for an inclusive classroom, to include online tools, to include models, to do project-based and problem-based learning to help our students to develop the 21st century skills. Thank you.
And now we'll hand over to our other member, Mr. Chris Campbell, for the question and answer section.
Good morning. We've got a few questions. One is just to kind of get some logistical things out of the way. This is from Nadine Ford. What was the preparation time and the duration span of the lesson? And I know we talked about 2 lessons, so maybe just answer both of that. What was the prep time and the duration span of the lesson?
Duration of the lesson was 80 minutes. That is in the week. They have their lessons once a week. The prep time was, I would say, the prep time, depending on them actually obtaining the materials and getting to class and everything. So they had to prepare before. I gave them about a week or so to get their materials together and get them into class, so we can then continue with the lesson, actually implement the lesson.
Anything, Conroy, but go ahead.
All right, in light of the secondary, that lesson plan was done by secondary students. In terms of the preparation time, I think it would be approximately 3 hours, because they would have to consult their lecturers in terms of the objective, in terms of the lesson planning, in terms of the instruction. The duration of the lesson was 2 hours. Thank you.
Thank you. We got a couple more in here. Just another logistical one. Where can we get all this information? This is a website. So where is this website address for our attendees?
Okay. Chris, I will paste the link for the website actually in the chat. All right, to make it available for everyone. Okay.
All right. And then one more was about differentiated instruction. What is the most important characteristic that differentiated instruction has from other teaching and learning techniques? So I don't know who wants to tackle that one.
All right. In terms of that, we are struggling some students are struggling in Jamaica in terms of not getting learning material. And so you have differentiation in terms of the process, in terms of the methodology. And so what I think can be done is that you can prepare lessons that students can use on their cell phone, they can use on their tablets without internet connectivity. In terms of the content, some person may have challenges in terms of reading ability, in terms of intellectual, in terms of analyzing. And so you will have to differentiate the content in terms of that. In terms of assessment, you could differentiate the assessment in terms of let's person dramatize things that instead of writing a pen and paper exam, you could ask person to create something. And so we differentiate in terms of the assessment.
Thank you, Conroy. Anybody else want to add to that? Differentiated instruction advice, important characteristics.
If I could just
The thing is, we need to know our students.
jump in for a
In
second.
order, yeah.
Claudette started first, Glenn, so go ahead.
Oh, sorry, Glenn. In terms of differentiating instruction, I think the project-based approach is a really good process to use. So in terms of differentiating the process of delivery of your instruction, it gives all of the children a chance to muck about with science, to do what they enjoy doing, which is creating things, finding out, observing, collecting information, all of these things that don't happen if they're just in a classroom being lectured to or being given notes on a board. So I would say if you're going in the direction of differentiation, start thinking about differentiating the process of delivery of that instruction and go for project-based learning. Thank you.
Glenn, you wanted to add something?
Yeah, I was just going to say, it's important in almost all aspects to know your students. If we can get to know our students, we'll understand their learning styles and we can adjust accordingly. We have to find ways to put tools in their hands and, like Claudette said, to muck about. They've got to have an opportunity to discover things on their own.
Okay.
And I'd just like to add that I find that for most younger students, when it comes to their learning styles, they're very tactile, auditory and visual, with the combination of that. Some are kinesthetic as well, as in they're always moving and like movement. And as Claudette said, to make your delivery and how you deliver your lessons using these styles will be good, because unfortunately for most assessments right now, we don't use those types of learning styles in our assessments.
All right, I know we're running short on time here. How about we have a social studies person, at least one. How can social studies be integrated in a STEM lesson? Just to be clear, the S in STEM is science, but I'm sure we can add some social studies in there. Anybody want to tackle that one?
I'm just going to take a stab at it. So let's say we look at Cheryl's lesson on the weather patterns across Barbados, or at least where her students live. So each of these students lives in a community, and the communities in Barbados are very strongly impacted by access to water. And so some communities are disadvantaged by not having good access to water, despite the rainfall that they might get in their areas. And so if you live in an area, for example, of low rainfall and poor access, then those communities would need to think about strategies to counteract that. For example, putting in tanks. And then you can think about, should the government help to subsidize these tanks, since it is no fault of these people that are living in these drier areas, and so on and so on and so on. Thank you.
I'll add to that one. Programs like ArcGIS help bring in that data, spatial awareness data, and so on. And then last one, I believe, is in terms of resources and teaching aids in this pandemic, how effective would it be carrying such a lesson? Well, I think, Conroy, you kind of presented on that, kind of presenting this or having these lessons both synchronous, asynchronous, virtual, in person, so on. Do you want to speak to that?
Okay. What I shared in the video was actually a software that can be used in terms of on your laptop, and also can use in your cell phone. It is also it's an offline and online tool, and so students without internet connectivity, once given the video, should be able to carry out that activity, and it will help them to develop the concepts and also critical thinking from that, because there are some questions that will guide the student to do active learning. In terms of the asynchronous, it can also be used in an asynchronous setting, in the sense that the teacher could use this as a platform for his or her lesson. In addition to that, it can also be used to conduct a lab setting. And so we are looking at recording and observation, not manipulation. So this can also be used for experimental purposes.
Thank you, Conroy. Anybody else want to speak to that question? I know Allison hadn't given us the boot yet, so we can add to that.
1 minute.
I guess I'll just quickly add that the materials that Cheryl chose are all materials that the children have easy access to. And so they could be doing these things at home, not necessarily in the classrooms. Barbados has chosen to go back into face-to-face classrooms, but that wasn't necessary in order for the children to create the devices, as Cheryl calls them, and to carry out the project. Okay, thank you.
And I would just like to quickly add that at present, our home is our lab. So let us keep that in mind, and we can use our open spaces and use cost-effective resources which are easily accessible, and do project-based learning, problem-based learning, active learning, everything right here at home, even though we are locked up. Thank you so much.
I think that's a great place to end. Our homes are our labs. I love it.
Right, and everyone can look in the chat. The link to the site is actually in the chat. And I'd like to give a special shout out to Allison. Thank you very much for helping to keep our team together. We are a crazy bunch, very crazy. Thank you very much. And I want to thank Rebecca also for organizing and giving me an opportunity and giving us an opportunity to meet each other. I mean, we all have different strengths, and I have learned so much, and I'm so blessed for having met you guys. So thank you very much for participating in our webinar presentation this morning.
Great, thank you all so much. Wonderful presentation, team. As for the rest of you participants, I'm just going to show you a little bit of information here quickly as we close out. We will be continuing promptly at 11 o'clock with the next session. So please stay here if you would like to participate in that session. It will be delivered in English with Spanish interpretation. So those of you who would like to attend a different session in another room, you can go ahead and exit out of this Zoom and go back into Gather Town and head to whichever session you are planning to attend. So thank you all so much, team. Wonderful presentation. We're so lucky to have you all and the great work that you've done. If anybody would like to reach out to these participants, please contact us at ITEN, and we will be able to give you a way to connect to these participants or these panelists. Thank you so much, team.
Allison, you're going to turn us into attendees, right?